Tim Cole is going to enlighten us about the upcoming transit of Venus. Here you go, Tim.
Thank you, thank you. Quickie, who saw the last one here? Good, most of us. Excellent. How many people are hoping to see the next one? Yeah, okay, perfect. Now, it is all up to you, of course, to sacrifice the requisite number of chickens to keep the clouds away, but it's up to you. Did I do the wrong thing again, as usual? There we go. Yes. So, we got a weird pattern happening here, in case you didn't quite notice. We had the last one 8 years ago, we have this one coming up, and then we've got nothing until 2117. And it turns out that there's an even weirder pattern. We've got a 243-year pattern, and there's been all kinds of mystical garbage about how, yes, but the year is 243 days, and it's a 243-year pattern, so the Mayans must have done it, or some stupid thing like that. But anyway, it's actually a fairly explicable pattern, but it's a weirdie. What it basically means is that you get 2 cracks in a lifetime, and if you didn't quite manage to get either one of those, you'd better hope that you can get very good vitamins. This is kind of a harbinger of the transit, because every 8 years we get Venus coasting through the Pleiades. We had this back in April, and that was kind of your indication that Venus is starting its little skydive down towards the ecliptic, and a little rendezvous with the sun coming up. So right now, this thing is just busily trucking right along. You can still see it up there. It's still fabulously bright. And I looked it up just for fun. It's exactly the same brightness as it was 8 years ago, to within about 1/10 of a magnitude. So that's kind of 1/100th of a magnitude. So that's kind of cool. We've got a descending node transit coming up. So what this is meaning is basically Venus is coming down to the plane of the Earth. Now, if you look from the top, what you're going to see here is that these transits, you might think would happen fairly frequently. We've got Venus zipping around inside, so every 1.6 years you should have an alignment. So why don't we get a transit every 1.6 years? And the answer is that the planet, the orbit is tilted. And in fact, we have to wait a little while longer before we can actually get an alignment near the nodes, which would suggest that you'd have a transit every 8 years, except, surprise, surprise, there's these little things called perturbations. So in fact, what we end up happening is that we have a close approach to the node, and we get 2 of them happening at once. So here we have back in 1988, when we had a fairly close approach to the node, and you can see here Earth and Venus, they just weren't close enough. So they were coming in fairly close, but Venus, the orbit of Venus is still moving around, it's still wobbling, it's still precessing. Moving 8 years into the future, it's getting tantalizingly close, but it's not there yet. And then back in 04, it's hard to see with the labels here, but basically you have these 2 spots, 2 almost bang on. And here in 2012, it's still very, very close. Now, as I've mentioned here, this viewpoint's from the sun, so this might be a little odd, but I found that the best way to visualize it. 2020, you can see here, it's zipping away. And by 2028, you can really see the pattern. So we're going to have to wait for another 105 years before everything starts to close up again. Then we get an ascending node transit in December. So I'm kind of happy that we've got this in June, because our prospects are much, much better for nice weather. The 1882 transit, there was a fellow that was observing up into Pean Point, and the only record I have of it said that he was snatching peaks through snow flurries. So we might have that here, of course, with this year's weather, but oh well, let's not worry about that one. So take a peek what's happened here. We have 2 sets of transit paths. Here's the one coming up, north side of the sun, and here's the last one, south side of the sun. A weird thing happens if it's actually a central transit. You don't get a transit. You don't get pairs 8 years apart. You actually get them, I think it's 124 years apart. But that's not supposed to happen, according to Jean Maes, until something like, I forget the number now. It's something like 5000 AD or something like that. So I'm not really waiting for that one either. This has been a weird thing. We've had a chance to see, well, if you include the ones we're in now, 6 pairs since the development of the telescope. 1631, we didn't get a chance to see it because basically the only place that had telescopes that we know of was Europe, and the transit wasn't visible from Europe, so there goes that one. 1639, we know of 2 people who actually saw it. This little guy who probably didn't quite do things exactly that way. He actually didn't make any drawings. The only drawings we have from him were done by Hevelius much, much later, so we really don't exactly know what he saw except from his descriptions. 1761, man, this was the period of massive, massive exploration. There's actually a new book that's just been released called Chasing Venus. Great book, written like a novel. Really good view of all the goings-on. And this was kind of wild. You're seeing international cooperation during the middle of the 7 Years' War. Well, an attempt at it, anyway. And the whole point of this, which we'll see in a moment, was to try and figure out the size of the solar system. By 1874 and 1882, I get the distinct feeling that it was as much at this point bragging rights as science. But there are some real hopes that the newfangled science and technique of photography was going to make it all wonderful. And, it did and it didn't. 04, I call it the amateurs transit because scientific interest was fairly minimal except for some very specific things. But here's the fun part. We found a few weird things happening in that transit, so we've got a little more professional interest coming up for the transit in another 26 odd days. So we'll have to see what comes out of that one. As I mentioned, the whole problem here was how big's the solar system? Well, Kepler gave us the solar system in terms of the astronomical unit, in terms of the distance between the Earth and the Sun. And with measurements, we could get very accurate ratios for everything. But we had that outstanding question, how big is the Flinken astronomical unit? And this is something that Kepler's laws simply could not tell us. After Sir Edmund Halley, a very intriguing guy. I wish I could get into a little more of him, but I don't really have the time, and you'd throw things at me. But he was a pretty cool dude, and he came up with this idea after watching a transit of Mercury. Realized that we could actually get the scale of it if we could observe the transit from two widely separated spots on the Earth. And by noticing the difference in the path lengths. Now, he realized that the problems of trying to measure this accurately were incredibly difficult for the time. So what he realized is you could get the equivalent from working out the time of transit. Because Kepler's laws could give us the exact angular speed. From that, we can work out the distance. That means we can work out the distance between these two lines. That gives us enough data to solve the triangles and give us the astronomical unit, at least in theory. You can see here, though, you're looking at very, very tiny differences. This is a set of images taken from 3 different locations for the last transit. You're looking at a really, really tiny parallax. So your measurements have got to be absolutely pristine and beautiful to make it of any value at all. And that's a problem because 1761, they discovered this very nasty little problem. The blasted planet didn't quite want to separate from the edge. And this threw measurements off to a vast, wacky extreme. You had astronomers working at opposite sides of rooms with measurements as much as 6 minutes in difference. So I mean, this was a major problem. They figured by 1769 they'd be able to solve this problem. There were people building all kinds of really cool transit gadgets so you could simulate the transit and train the astronomers. And it didn't seem to solve the problem. So the 1761 transit was a bit of a disappointment. The distance for the astronomical unit was all over the place. 1769, after a tremendous amount of work, they came up with a number that turned out later to be reasonably good. Now here's your very own black drop. And it's basically an effect of diffraction and having a very bright background behind. Now it actually turns out that you can take advantage of that to get around the problem of the black drop. Now, we actually had some reasonably good observations, or at least some fun ones last time. This was one of the earlier SmartScope results. We very quickly threw a solar filter together for that and ended up having to put 2 layers of bad or solar film because the camera was too sensitive. We were fighting with clouds, but it doesn't matter. We did finally manage to get a good view of it. You can sort of see a hint of black drop here and another hint of it here. This is the classic method. Aim your camera into a telescope, and it's amazing how well that works. Interestingly enough, it doesn't work well with the modern smartphones. They're too smart. The electronics in the cell phone basically seem to say, oh, yes, I must make this 18% gray and completely foul up the astrophoto. The old, dumb, stupid ones did a great photo, but not anymore. So here we have the circumstances. Yes, June 5th. If you look up your trusty astronomical handbook, you will see it is listed as June 9th. That's because the times are in Greenwich Mean, and it's June 6th for the Eastern Hemisphere and June 5th for us Western Hemisphere types. So I'm really pitying some poor bugger who's going to go out there, get up in the morning of June 5th and say, oh boy, this is going to be really, really cool. Oh, crud. So, don't be one of those poor buggers who gets up on June 6th and says, oh, crud. Damn, I'll have to wait till 2117. Oh. So we're looking at first contact, in other words, touching the outside, and second contact, you can see here, a good 20-odd minutes later. So, this is where really the fun is for us here in Ottawa. You can get to see a fair chunk of the start of it, and this is where the interesting stuff will happen. The rest of it's fun too, but as usual, it's entry and exit into any kind of a transit that I find the fun bit anyway. So here's the circumstances for us, and you can see here this lovely little statistic: 67% chance of significant cloud cover, and that's from long-term averages. So we get a chance to actually see a fair chunk of it before sunset. This, interestingly enough, you can see here the pattern that it actually takes when you see it from the ground. So we've actually got a fair chunk of time to see the transit. So as long as you can even get quick peeks through the clouds, we got a good chance of seeing something. So where is a good place to see it in the world? This one's a Pacific Basin transit. This, you can see here, this is where the great places are. I checked out to see what commercial expeditions were happening. There is actually a commercial expedition starting from Ulaanbaatar. And then from there they go to the Gobi Desert. And I know there's one academic group that's doing it, but oh well, to each his own. There's a commercial trip to Siberia. I know of another one to Tashkent, which just doesn't make any sense to me, but I guess. There's several to the Hawaiian Islands. There's at least one in Queensland. And there's at least one I know of that's going to Tahiti. And the nearest thing I can make out, this seems to be historical purposes. They seem to be retracing Cook's expedition. One of them is the Cook Society. But there's a lot of interest happening in Hawaii. You can just barely get the whole transit from there. And in fact, you were going to see a webcast done from the NASA Edge people from Mauna Kea. So we ought to be able to at least get that here if the weather doesn't cooperate. Now, there's all kinds of tales to the transits. It's an incredible set of tales for everybody. And it was weird enough that actually a Canadian playwright by the name of Maureen Hunter put together a play and later the libretto for an opera on the exploits of probably one of the most unlucky astronomers in human history. The guy who became known as Lejonti because the rest of his name was about 6 names long. I can't even remember all of it. Jean-Baptiste Hyacinthe Le Gallois Reed, McDonald's, Harvey's, whatever. Anyway, so Lejonti, that'll do. This poor devil goes down to see the 1761, gets rushed off by combat, goes out to sea and sees it, but can't get any measurements, sticks around for 8 more years to see the next one, is told by the French Academy of Science, no, you can't observe from Manila, you must observe back from India where you tried to the last time. Barely makes it to Pondicherry on time, is clouded out for the 1 day of the transit. In fact, the clouds broke after the transit was over. He discovered later that it was perfect in Manila. And then had to make his way back to France and discovers that his heirs have had him declared dead so they can steal his estate. Basically. If somebody did a bad soap opera about it, you wouldn't believe it, except it actually happened. Now, you also have, for this time around, we have Venusian Brew. There's a microbrewery in Michigan that's actually doing Venusian Ale. There's a competition now for the name of said Venusian Ale, but it's supposed to be tapped, I think, later this week. Now, for those of you who know me a little better, I was quite happy to discover Venusian Black Drop Coffee. So I was much happier with that one, not being a beer drinker, but being a coffeeholic. So all the stuff's around. I actually recently discovered Venusian Pizza. Done in the same city that has this livery microbrewery. There's a Transit of Venus pizza and a Black Drop Effect pizza. Yeah, it must be the Black Olives. There are also Venusian apps. There's an app for that. Basically, what this will do is give you a chance to put in your recordings, put in your measurements, transmit them to a central server in the Netherlands, and it should be able to give you real-time update on the current estimate of the length of the astronomical unit, which, of course, I mean, it's just a fun thing. I mean, to try and repeat the calculations. It's a lovely exercise in science and math, and to be able to do this in real time. Hallie would have just loved it. You can just imagine this guy thinking this would have been just the grandest thing since, British ale or stout or something, or whatever the heck Hallie drank. He was actually quite a ruffian in his time. He was generally regarded as a non-gentlemanly gentleman, who was reputed to swear like a sea captain and to drink like a drunkard, and basically he was quite the wretch. I think he would have been a wonderful fellow to know. Now, the last time around in '04, we got a really good view of what happens with the black drop. And this is where some of the interesting stuff is happening. You can take a look right down here, where it's starting to come in. And if you look really carefully, look at this lovely little line forming there. So it turns out that we do have a diffraction effect. It's a real effect. It's not just an optical illusion, but it's worsened by bad optics. And this was probably the trouble they had back in the 1760s, that their optics just were so poor that you were getting a lot of the effects on it. But you're also seeing this beautiful little line there. So it turns out that by taking advantage of knowing what's happening, you can actually get your timing really, really accurate. Of course, it's kind of a moot point because now we have much better ways to work out the astronomical unit. But this is interesting for people looking at transits of exoplanets. So for this time around, there's a number of teams that are going to be looking to calibrate techniques and equipment using the known characteristics of Venus to try and dial in a better way to handle exoplanet transits and try to work out the details for that. So this is kind of fun. This chap here, Lomonosov, interestingly enough, this guy had a temper that made Isaac Newton seem like a quiet, gentle fellow. Basically, yes, those Russians, he probably would have scared Rasputin. But he made the first reference to basically a disk around the planet. His writings were a little fragmentary, and there was lots of debate for hundreds of years as to whether it truly existed. And we were able to put that to pasture the last time around. I mean, we know that it's an atmospheric effect, and he was the first guy to suggest an atmosphere around Venus, and actually started suggesting extraterrestrials and all that good stuff, which we now know would be boiled, fried, baked, and sautéed on the surface. But this little atmospheric line here, now this is inspiring considerable interest because some interesting things are happening. Take a look down here. There's a bright spot here at the pole, and it turns out you can get a bright spot up here at the other pole, and you're actually seeing the effects of the atmosphere compressing a bit at the poles. So you're actually getting a sense of the orientation of the planet, and there's a number of teams that are hoping that this will give us some really good insight into estimating details of exoplanets. Again, you're seeing increased diffraction here, so increased refraction here, so this may give us an indication. And you can see here, you can see the atmosphere around it. This has been slightly enhanced. It's contrast enhanced just so you can see it a little better, but they haven't done excessive image processing on it. So this is going to be a fun one to check out for this. So any of us who have a chance to look through reasonably large telescopes in good conditions, it'll be kind of fun to see what you can make of the Aureole. Never mind. The round, disky, brighty thingy. Technical terms are terrible. The big thing you got to watch out for is artifacts. This one here is from the Swiss Solar Telescope in the Canary Islands. They did a little bit of contrast enhancement to show it on their pretty picture for the publication, but other than that, they didn't do too much. This is an image where basically it's incredibly overprocessed, and you had to be careful processing it because you could end up with images that just don't exist. The brightness of the atmospheric ring is in fact dim enough that it's going to be blasted out by the sunlight behind it. So anything like this is purely fictitious. But you can see how if you had this level of processing right here at the edge, you could end up with something that's completely bogus. So something to watch out for when you're processing your stuff. But this is a chance here where amateurs could actually do some really cool stuff as usual. So you got fun things happening for the transit. You've got bragging rights, and you've got some possibilities of science. Now, you'll see that we're handing out, for the upcoming events, you'll see that we're looking at handing out eclipse glasses, and a lot of people are doing this. So there's a test that was suggested in the last Sky and Telescope on whether or not you were actually going to be able to see Venus through those eclipse glasses. So this is roughly to scale. Thank you, Glenn, for doing a good job of keeping us reasonably honest. Right up there at the top, you see the little dot of Venus against a reasonably scaled sun. So for those of you in the back row, if you can make out the dot here, have fun with the eclipse glasses because you're actually going to see something. From the middle row, if you can see the dot here, again, Bob's your uncle. And from the front row, if you can see the dot here. So, I mean, this isn't intended as a test to embarrass you. I mean, everybody's got different visual acuity. My visual acuity is awful. My wife's is perfect. She's not into astronomy. There ain't no justice. I can barely make out the dot myself, naked eye or through eclipse glasses. So, but some of you will. So this will give you a sense as to whether you're wasting your time trying to do anything with the eclipse glasses. Many of you will find it's going to work. Some of you will find it won't. And this is kind of nice to give you a sense of it. We'll give you the details on it. It's actually in Sky and Telescope, but basically it's scaled discs to give you a sense of whether or not you're going to see it. So there you go, folks. 26 days and counting. Sacrifice the chickens. Hope like heck everything works out. And top of the list, though, have some fun with this one because we're talking Major League bragging rights. Okay, folks, enjoy.